Hi all, so welcome to the today's tutorial. So in the previous tutorial we have done the braking system and acceleration was working fine, and we have given some rotation too. So this is our vehicle. So today we will add this tire to our vehicle because right now it is our vehicle is pretty good to go, but see it is like it is without wheels, so it is not fun. Okay, so let's start our tutorial. So first thing what we will do, I will like remove the collision from it, because right now the collision it was having some issues, but it was having some hexagonal type shape. So I have removed the collision because I don't want that. And let me open my IDE. Give it a second. Okay, so first thing is we will create a using component, like we have created the arrow component. So today what actually we will do, so we have arrow components which we have plugged in before. So there are 4 arrow component. We will create 4 scene component which we will attach to the position. Like here we will add some offset as soon as our wheel will go and down, so we will just move around the scene component, and we will attach our vehicle mesh, sorry, the wheel mesh, to this component. So this is our idea. If you have some idea like how you can implement that with the clever approach, just let me know, and we will figure it out. Okay, so you property, I will just use the same settings which I am using everywhere. Blueprint read only. Okay, so it will be the use scene component, and you feel scene, and it will be front right, and I will just duplicate it 4 times. It will be front left, it will be rear right, and it will be rear left. Okay, so our scene component is done. Now we will initialize it. So we will just go to the cpp file, and we will go inside the constructor. Let me go. Okay, let's here, and we will attach it to the arrow component. So make sure that you are defining these classes after the arrow component. Okay, just a second. Okay, so wheel scene front left or frontal right equals to create default sub object and use scene component text, and I will give it the same name. This is what this is the convention which I follows. I always keep the name same so I don't get confused. And wheel component will set up attachment, and I will attach to the arrow component. Arrow front right, sorry, arrow front right, or the front left. Okay, and I will just duplicate this 4 times. So it was front right, will be front right, and I will connect it to front right, and this was rear right, and this will be rear right, sorry, and this will be rear right. It will be rear left, it will be rear left. Okay, same with here. Okay, so now previously when we have defined our arrow, so what we have done, we have created a container for the arrow, if I'm not wrong. Have I? Let me check. Yes, so it was wheel arrow component holder. So we will do the same for this one, and so let me write it the array u scene component, and it will be the wheel scene component holder. Holder depicts like it have many items, that is why we haven't prefixed s. Okay, so let's back to the cpp pp class, and we will initialize it in the begin play. We can also initialize it in the post initialize component, and it is the good idea to put it everything like in the post initialize component, because our like initialization will be completed in the component side. Okay, but okay, just for the like this tutorial sake, we'll scene component holder is equals to uh, wheel scene front right, wheel scene front left, wheel scene rear right. Okay, he wheel scene rear left. I'm just using the same order which I have followed before. So wheel scene rear right. Okay, front right, front left, rear right. Okay, like it doesn't matter here, but it will make sense here because we have to sync these two. Okay, so next thing is which we have to do, we have to just give me a sec. Okay, so first thing we will set is the rotation, like left to right, when we will steering the wheel. So previously we have written this the current steering angle, and we were adding some torque there, and this was the current angle. Okay, so what we will do, we will just check if arrow index wheel arrow index is less than 2. That means, because I just want the front tires, and I know like in the container we have 4 elements, and the front 2, like in the above 2 are the front tires. So I will just wheel scene component holders and index, I think it was arrow index if I'm not wrong, arrow index, yes, is equals to set relative rotation, and I will we have to put the f rotator and 0 0 and current steering angle. So what I have done here, let me explain. So this scene component is just right now it was just stick to this arrow component which we have placed before. So when we will rotate our vehicle, we know that I am moving my steering angle from minus max steering angle to the max steering angle, and we were saving this value to the current steering angle. We are just setting this value to the z axis rotation. Why? Because when we will rotate our like wheel, so the xy will remain same, only z, like I just want to rotate the z. So that is why I'm doing this. So let's go forward. So this is for the steering, and now we will check for the location. For the location, let me check. Okay, yes, so let's come in the end here. Let's wheel scene component holder arrow wheel arrow index and set relative location, and here I will let f vector spring length, spring travel length, no, this one is spring length. Let me check what we have. Okay, spring length, it should be the one. So spring length, wheel arrow index, comma 0 comma 0, and yep, if I'm not wrong, we are good to go. Let's see why we are doing this. So when we will attach this scene component, so their x value will be in the downwards direction, because these arrow components are in the downward direction. So that is why when we will set the offset, then we will give the offset in the x direction. So let's get back here. So when I'm setting the relative location, I'm setting the spring length to the x-axis, not the y and z axis. So you know the reason why. Okay, and okay, now we are good to go. Let's compile the code, and I have made change in the header files too. So I will just close my Unreal, and I haven't saved that asset, I guess. So I will check that, and let me again rerun it. Okay, it is up. Let's get back to that vehicle base. Let me check if we have everything in the place. I have put the scene component. Okay, front right, rear left, rear right. Okay, so front left, I think we haven't got wrong. Front left and front right. Let me close it and let's check what we have done wrong. Uh, okay, front right, front left, left, rear right. And when we are attaching it, we'll. Oh, okay. This is my mistake. Let me copy paste it. FL for RL. Okay, that should be good. Control B. So the difference between Control Shift B and Control Shift B will compile the whole program, and Control B will just compile the selected project. So make sure, like, if you have multiple projects, you can just press Control B. And I guess I haven't told you like what exact calculations I have did. So let me check for the wheel now. Wheels in component, if they are in place. Yes, they are. So this is rear left, rear right, front right, and front left. Okay, they are good to go. Now what we will do, we will attach our wheels to them. So let me select. I haven't tested that out, like, to add the multiple. So static mesh. Okay, no, they are okay. Let me check, and let me put that wheel on. So here the car tire. Okay, let me copy, and I'm going to paste it over the. Sorry, I have to just make sure that. Okay, I think I have to reparent them. So just let me reparent them again and again. Okay, guess they're sorted. They are in order to. Okay, and we can give some offset, but it doesn't matter, like, even though, like, if you will not put them in place, still, like, they will become in place. Okay, control. Let me check if they are there or not. Yes, they are. So the vehicle rotation is working. So right now it is looking like they are sliding. Yes, so we have to tweak that value, but it is working, and it is working very smooth. And when we are rotating our car, it is rotating very fast. So what we can actually do, we can add one more setting in here, like, because our med. Okay, so that is working fine. So only the rotation is remaining, so which we will do it in the next part. And there's one more thing, yeah. So we have to add one damping here, because angular damping uh, is 0. So that is why what it is doing, it is heavily moving. So now let's try. Now it is very much controlled. See, let's get back to that. Awesome. Cool. Awesome. Awesome. Let's check for the spring arm, and I will. There is one. Okay, camera lag is already there. Okay, awesome. So this was the today's tutorial, but we can also add the rotation to the tire. Okay, go down. So let's check the calculations first. So how we will do? So first we will see the velocity. Velocity equals to distance upon time, correct? So we do have velocity because we have calculated it, if I'm not wrong. Yes, we have a function called for get. So we have world linear velocity and local linear velocity too, and we will just consider the x value because we are moving in the x direction. So we have velocity. We have time also because we can use the delta time, which we can get in every frame. So we have these two. Using these two, we can get the distance. So distance will equal to velocity into time, correct? Now the relation between distance and the angle, how we will do that? So 360 degree is equals to 2 pi r. It is a circumference. So where r is the radius of the that circle. So 1 degree, so this is the distance, correct? So 1 unit distance, if I have to calculate it, I will like take this and I will move it under this. So it will become 360 upon 2 pi r. So it will become 1 unit. So it is 1 unit distance, and we have d, which we have calculated after multiplying v and t. So it will become the total, like it is so this thing is in degree. So if the d is, so d will equals to 360 upon 2 pi r into d, and d is v into t. So this is the calculation which we need to apply. Okay, so let's begin our calculation then. Okay, for for rotation, when I will add the rotation to the tire, it will for every component, correct? Yes. And so we will scene component holder, wheel arrow index dot add local rotation. So first thing, the rotation will be in the x y because it is downward. So this axis y we will see, and in other axis it will be 0 0. So this thing we have to calculate. So it was 360 into, so 360 into v into t. So and as for the calculation, 360 into, so velocity is I think local linear velocity dot x into time is delta time, and upon we have 2 into the pi value is 22 by 7, in short 3.14, into r. So r, we can have a wheel radius, so which we don't have. So wheel radius, this value we don't have, so we will create it. So press this button. Okay, this add okay, let me create it. Oh, we do have it already. This is nice. Okay, and okay, I have to add one more f rotator because we are calculating the rotation here. So let me again wrap it. Okay, so this should work. Let's see if it is working fine. So control B, because we haven't made changes in the header file, so it should be good to go. Now it is working fine and it is very smooth. But I think that rotation is working, but give me a second, let me rotate it a little. spring arm, compile. Okay, they are moving in the opposite direction, and my front tire is not moving, correct? Okay, so let's see what we have done wrong. Okay, so I got the problem. So what we are doing, we are setting the relative rotation, and we are doing in the same function and in the same frame in which we are adding the local rotation. So if we will comment this picture out slightly and control B, let me compile it. Yes, it's compiled. Let me check. Now it is fine, and they are rotating in the reverse direction. So let me multiply it with -1. So just give me a second to -1 just for the opposite direction. Control B. Now they should be good to go. Now you have to find out like what we can actually do. Like one suggestion which I can give you, like you can add one more hierarchy to the components. Like right now they have like this is like that in the front tire, or like you can add one more hierarchy and you can add local rotation there, and you can just provide the raw rotation which the week like the wheel is rolling, you can provide it to this, so you can use that. And just after doing that you can comment me below. So now it is very smooth. As soon as I'm pressing brake, it will stop the vehicle. See, it is very smooth. So I do like it, like the outcome of this vehicle is very smooth. If I if you will go up, the suspension is working great, so this is actually good. So the rotation thing you have to find out and just comment me below, like what do you think, like, and what are the approaches which you can take, and then in the next tutorial I will tell like what is the best method to rectify this. Okay, if you like the tutorial, please like and subscribe. Thank you, take care.